cells that promote muscle repair have a dark side, a tendency to change so radically that they actually cause wasting and scarring rather than healing. A team led by Sanford Burnham Prebys Medical Discovery Institute discovered this transformation in mouse models of amyotrophic lateral sclerosis, ALS, spinal atrophy and spinal cord injury. The discovery could inspire new ways of treating those and other neurological conditions. The muscle repair cells that the researchers zeroed in on are called fibroadipogenic progenitors, FAPs. By studying the mice, along with muscles from ALS patients, they found that FAPs activate a signaling pathway called IL-6-STAT3, which in turn alerts the immune system to go into overdrive, causing muscle wasting. When they block the pathway, the muscle wasting stopped. They published the discovery in the journal Nature Cell Biology. Senior author Pier Lorenzo Puri, MD, called the characterization of FAPs a critical step forward in the understanding of motor neuron diseases. Now we can start working on designing medicines that target these cells or possibly use them as markers of disease progression, which can't come soon enough for patients and their caregivers, said Puri, professor in the Development, Aging and Regeneration program at Sanford Burnham, in a statement. Biopharma is a fast-growing world where big ideas come along every day. Our subscribers rely on Fierce Biotech as their must-read source for the latest news, analysis and data in the world of biotech and pharma. To read on the go, sign up today to get biotech news and updates delivered right to your inbox. Related, CRISPR reveals possible ALS drug target. Puri's team made their discovery by tracking many of the key players in muscle repair, including stem cells and macrophages, which are immune cells that clean up debris. They found that when muscles sustain acute injuries, FAPs show up after macrophages but before stem cells, and they leave within about a week, when the muscle is well on its way to recovery. But when there is muscle denervation, meaning a loss of neurons, FAPs gather in high numbers inside muscles and never leave. The scientists could not find signs of macrophages or muscle stem cells in denervation models. It was when they studied the odd FAPs more closely that they found elevated levels of IL-6, an inflammatory protein that promotes muscle atrophy. Despite a history of failed drug development in neurological disorders, the biopharma industry continues to pursue new ideas, particularly in ALS. Just this week, Biogen struck a $535 million deal with AliveGen, for example, to develop drugs for muscle wasting disorders that block myostatin, which regulates muscle function. And startup Equina Pharmaceuticals is pursuing therapies for neurodegenerative diseases that target stress granules that form in response to injury. Academic researchers are progressing in their efforts to better understand the underpinnings of ALS and other brain disorders. Scientists at Stanford announced earlier this year that they used the gene editing system CRISPR-Cas9 to discover a gene that can be blocked in order to shield neurons from cell death. The next step for Puri's team is to better characterize the IL-6-STAT3 pathway, to help promote the development of medicines to target it. Now that we have found a key difference in these FAP cells, we have an opportunity to selectively remove the bad, disease-causing cells, or convert the cells so they can repair nerves, he said.